Hi guys, in this video we are going to take out our rubber band lab part 2 that we use to collect data in class. If you weren't here, you're going to use the sample data that I've posted on Schoology, and we're going to use this data table to turn it into a graph. If you have already completed your graph, you can skip this video and go to the next video. First, we need to use this graph and set it up so that it can fit our data. First, we can title our graph. Now remember, this whole lab was testing the effect of the stretch length on the average distance. Those variables help us very much to create a strong title. I'm going to call this title the effect of stretch length on average distance. About out of space, I'm just going to wrap around the side. Next, we need to label our x-axis and our y-axis. I've actually given you these labels right here, so you can just copy them down. Our x-axis, which is our horizontal axis, measures stretch length, and our y-axis is measuring average launch distance, so we can label it average launch distance on the side. Now, I'm going to help you do this, and no matter what your data looks like, this is going to be true for you. We need to fit along the x-axis all of these distances, 20 centimeters all the way to 40 centimeters. So along the bottom of this chart, remember, we need to make hops that are all the same size for the entire x-axis. Since we need to get at least to 40, the best idea here is going to be to count by fives. So I'm going to say 5, 10, 15, 20, 25, 30, 35, 40, 45, and you can keep going, but we're never going to go beyond 40. For the y-axis, if we look at our data, at least for my data, we have everywhere between 300 and almost to 500. So we need to get at least to 500. I would recommend that we count by 50s to get that to fit. So 50, 100, 150, 200, 250, 300, etc. I'm going to write all the way to 550. You could keep labeling all the way to the top, but I'm going to stop there. This will be able to fit all of my data. Now I'm going to show you how to plot a couple of these points, and you're going to finish by yourself. So first, all that I care about is the average and the stretch length. So here, with a stretch length of 20 centimeters, my average distance is 303.3. I'm not going to be able to be that precise on this graph because I'm jumping by 50 every line, but we could say at 20 centimeters, the rubber band traveled just over 300 centimeters. So that is where that point is going to go. For the next point, for my data, at 25 centimeters of stretching, the rubber band traveled 363.3 centimeters. So I'm going to say at 25 centimeters of stretching, it traveled 363.3, which is significantly above 350. All right, so you're going to plot 5 points so that you have a point for each of the stretch lengths. Once you've got 5 points, you're going to connect them dot to dot with straight lines. So I've got 2 connected. I'm going to be adding 3 more points and connecting them all with a straight line. Then I'll be using this graph to analyze and answer the questions on the back. So once you've finished your graph, you can go ahead and watch the second video. Thanks.